Given that the function fx equals square root of 2x plus 1 satisfies the hypothesis of the MVT, the mean value theorem on the interval 0, 4, find the value of c in the open interval 0, 4, which satisfies the conclusion of the theorem. Okay, this graph is optional information here. To answer this question, we don't need to graph. But anyways, this is the red is the curve y equals, or fx equals square root of 2x plus 1. And we are interested on the interval 0, 4, 0. So we'll be there, and 4, okay, will be there. And if we join a line that's called a secant line here, this is secant line, okay, that's the secant line. Then we can find the slope of secant line. That's just the rise over run. Then the mean value theorem says we can find a point, okay, a x value somewhere here, which is called c. I don't know where. That's on the curve somewhere, so that we can draw a line parallel to this one. We can match the slope of this secant line. So theorem says f prime c, that's the slope of the tangent line at some point, equals slope of this secant line. If we say this one is, let's say this is a, function of a, and this one is b, and this will be function of b, that is fb minus fa. Okay, that's the rise over run, b minus a. Rise means from here to here, that's the rise, and this one is run. And then using this is the statement of the mean value theorem. We are supposed to find c. Okay, this is a is 0 and b is 4. So this is slope of secant line, and this one is find the derivative and then evaluate it, c, that's the slope of tangent line. Okay, c will be somewhere here, I don't know, and then we can draw a tangent line which will have the same slope as this secant line. That means the tangent line will be parallel to secant line. Okay, this is slope of tangent line at c. Okay, this is all optional. All we have to do is, whenever we find a mean value theorem problem, all we have to do is find slope of secant line, find slope of tangent line, which is find the derivative, then set them equal and find the value of c. Okay, let's find the slope of secant line first. Okay, slope of, I mean, you can just think this one is just the total work for this problem. Slope of secant line. So we have curve and points are 0, 4. So we need to evaluate this function at 4 and at 0. This is 2x plus 1, so 2x is 4 plus 1, 8, 9, so this is 3. F at 0 is 2 times 0 plus 1, 2x plus 1. I'm just evaluating the function. This is 1. Then the slope of secant line is, this is 3 minus 1, that's the rise, f4 minus f0. At where? 4 and 0, 4 minus 0. Okay, pretty much I'm doing f at the next point minus f at the previous point divided by b minus a. Okay, 3 minus 1, that's the rise. Run is from where? 0 to 4, so 4 minus 0. This is a, this is b. So this is 2 over 4, which is 1/2. Now we need to find the slope of tangent line. For find the derivative here. What is the derivative of this function? So our function is square root of 2x plus 1. Square root means 2x plus 1 raised to 1/2. So from the chain rule, its derivative is then from the power rule 1/2 2x plus 1 1/2 minus 1, negative 1/2 times from the chain rule, derivative of inside. So 2. 2 and 2 cancel. This negative exponent put on the bottom over 2x plus 1 raised to positive 1/2. Negative becomes positive. This 2 and 2 cancel. Okay, this is 1/2 means the square root, pretty much 1 over square root of 2x plus 1. Okay, then by the MVT, this slope equals this slope, 1/2. And now we solve for x, and that x is indeed the c we are looking for. Slope of secant line, sorry, this is slope of tangent line equals slope of secant line. Cross multiply, so square root of 2x plus 1 equals 2. Now square both sides. 2 squared means 4. Okay. Subtract 1. We get 3. Okay. Subtract 1. Now divide by 2. 3/2. Thus, the C we are looking for, or guaranteed by the MVT, is 3/2.